Compounds of Noble Gases Part 3. Hi everyone, I am Dr. Digna Varghese. Now let's get started. Compounds of Noble Gases Part 3. What I want to share with you in this Part 3 of Noble Gases: structure of xenon oxides, structure of xenon oxofluorides. Let's start structure of xenon oxides. Xenon trioxide is the first oxide compound. Molecular formula of xenon trioxide is XeO3. In this compound, xenon is in +6 oxidation state. Xenon trioxide is an unstable compound of xenon. It is a very powerful oxidizing agent. It liberates oxygen from water slowly. It can be accelerated by exposure to sunlight. It is dangerously explosive upon contact with organic materials. When it detonates, it releases xenon and oxygen gases. Xenon trioxide. Its synthesis: when xenon tetrafluoride undergoes hydrolysis, giving highly explosive xenon trioxide along with xenon gas, aqueous hydrogen fluoride and oxygen gas. Another method for the synthesis of xenon trioxide is xenon hexafluoride undergoes slow hydrolysis, giving xenon trioxide and hydrogen fluoride. Structure of xenon trioxide. Central element in xenon trioxide is xenon. Atomic number of xenon is 54. And the ground state electronic configuration of xenon is krypton 4d10 5s2 5p6. The outer electronic configuration of xenon in the ground state is shown here: 5s2 5p6 5d0. In the case of xenon trioxide, there are 3 bonds between xenon and oxygen, that is 3 sigma bonds between xenon and oxygen. Therefore, a xenon atom needs 3 unpaired electrons to make 3 bonds with oxygen atoms. According to valence bond theory, the bond is formed by the overlap of half-filled valence atomic orbitals of each atom containing 1 unpaired electron. This is possible only if 3 of the 5p electrons of xenon atom is promoted to an empty 5d orbitals of the same xenon atom. Therefore, the excited state of xenon is having electronic configuration krypton 4d10 5s2 5p3 5d3, that is 5s2 5p3 5d3 is the excited outer electronic configuration of xenon. Therefore, the 5s and 3 5p orbitals undergo hybridization and forming a new 4 sp3 hybrid orbitals. We know hybrid orbitals are differ only in orientation in space. sp3 orbitals are oriented in tetrahedral fashion and the bond angle is 109.5 degree. One of the sp3 orbitals contain electron pairs, but the remaining three are half-filled orbitals. In this sp3 hybrid orbitals, one sp3 hybrid orbitals having electron pair and the other three are in the half-filled state. That means that contain one electron each. The three half-filled sp3 orbitals overlap in a head-on fashion with the half-filled 2p orbital of an oxygen atom, each to form 3 XeO sigma bonds, thereby forming XeO3 molecule. The three unhybridized 5d orbitals remains there and each can overlap in a sidewise fashion with the remaining half-filled 2p orbital of the same three oxygen atoms to form 3 XeO pi bonds. This pi bond is from d orbital of xenon atom and p orbital of oxygen atom. So it is known as d pi p pi bond. The XeO3 molecule thus has a pyramidal structure because the three orbitals containing half-filled orbitals which can overlap with the 2p orbital of the oxygen atom and forming sigma bond with the xenon atom, and one sp3 orbital contain electron pairs that act as a lone pair. Therefore, it has a pyramidal structure, and the bond angle between the xenon oxygen bond is 103 degree due to the greater repulsion between the lone pair and the bond pairs. Number of lone pairs in this XeO3 molecule is 1 and number of bond pairs is 1, 2, 3. 3 bond pairs and bond angle is 103 degree. Therefore, the geometry of the molecule is pyramidal structure. Xenon tetroxide. Its molecular formula is XeO4. Xenon in this compound showing its highest oxidation state, that is +8. It is a yellow crystalline solid. It is relatively stable. Xenon tetroxide. Synthesis of xenon tetroxide when barium perchenate is reacted with the sulfuric acid, giving percenic acid which is unstable. This percenic acid on dehydration gives xenon tetroxide. Structure of xenon tetroxide. Central element is xenon and the atomic number of xenon is 54. The ground state configuration of xenon is krypton 4d10 5s2 5p6. The outer configuration of xenon is 5s2 5p6 5d0. We know in xenon tetroxide there are 4 sigma bonds between xenon and 4 oxygen atoms. Therefore, a xenon atom needs 4 unpaired electrons to make 4 bonds with the oxygen atoms. This is possible by the promotion of an electron from each from 5s and 3 from 5p orbitals to empty 5d orbitals. Therefore, the excited state configuration of xenon is krypton 4d10 5s1 5p3 5d4. The outer excited state of xenon atom is 5s1 5p3 5d4. The 5s orbital and 3 5p orbitals of xenon mix among themselves with redistribution of energy to yield 4 new sp3 hybrid orbitals. The 4 sp3 hybrid orbitals are oriented in a different fashion. That is, sp3 orbitals are oriented in a tetrahedral fashion and the bond angle is 109.5 degree. The 4 half-filled sp3 orbitals overlap in a head-on fashion with the half-filled 2p orbital of an oxygen atom to form 4 sigma XCO bonds. There are 4 unhybridized 5d orbitals are there and that contain an unpaired electron each that can overlap in a sidewise fashion with the remaining 2p orbitals of the same 4 oxygen atoms and forming XCO d pi p pi bonds. Therefore, the structure of the xenon tetroxide is tetrahedral and there is no lone pairs, only 4 bond pairs. So the bond angle is 109.5 degree. Now we are going to discuss the structure of xenon oxofluorides or xenon oxyfluorides. First compound is xenon oxodifluoride. Second one is xenon oxotetrafluoride. Third one is xenon dioxo difluoride. And fourth, xenon dioxo tetrafluoride. Fifth one is xenon trioxo difluoride. Xenon oxodifluoride molecular formula is XeOF2. Synthesis of xenon oxodifluoride: when xenon tetrafluoride undergoes hydrolysis at low temperature, say minus 80 degrees Celsius, giving xenon oxodifluoride and hydrogen fluoride. In the case of xenon oxodifluoride, central element is xenon and the atomic number of xenon is 54 and the ground state configuration is krypton 4d10 5s2 5p6. For the xenon oxodifluoride, xenon forms 3 sigma bonds and 1 pi bond. For this, electrons promoted from 5p orbitals to 5d orbitals. After excitation, the electronic configuration is krypton 4d10 5s2 5p4 5d2. The outer electronic configuration after excitation is 5s2 5p4 5d2. The 5s orbital and the 3 5p orbitals and one of the 2 5d orbitals of xenon mix among themselves with redistribution of energy to yield 5 new sp3d hybrid orbitals. sp3d orbitals are oriented in a trigonal bipyramidal fashion. 3 of the 5 sp3d orbitals are arranged in a plane and one of the sp3d orbitals are above the plane and one is below the plane. The equatorial sp3d orbitals making an angle 120 degree and axial and equatorial orbitals make an angle 90 degree. And two of the three half-filled sp3d orbitals overlap in a head-on fashion with the half-filled 2p orbital of the fluorine atom and forming two XeF sigma bonds. One of the three half-filled sp3d orbitals overlap in a head-on fashion with the half-filled 2p orbital of the oxygen atom and forming XeO sigma bond. The half-filled unhybridized 5d orbital form a d pi p pi bond with the remaining half-filled 2p orbital of the same oxygen atom to form one XeO pi bond. The two lone pairs on xenon occupy two of the equatorial positions in order to minimize the repulsions. The number of lone pairs is 2 and number of bond pairs is 3 and the bond angle is less than 90 degree. This is because the greater magnitude of repulsions caused by the lone pairs. The geometry of the molecule is T-shaped structure. Xenon oxotetrafluoride. Molecular formula is XeOF4. It is extremely reactive and unstable. Synthesis of the compound when xenon hexafluoride undergoes hydrolysis giving xenon oxotetrafluoride and hydrogen fluoride. The structure of the compound, the central element is xenon and the atomic number of xenon is 54. The ground state electronic configuration of xenon is krypton 4d10 5s2 5p6. The promotion of an electron each from 5p orbitals into 3 of the vacant d orbitals takes place, which gives its excited state as 5s2 5p3 5d3. The 5s orbital and the 3 5p orbitals and 2 of the 3 5d orbitals of xenon mix among themselves with redistribution of energy to yield 6 new sp3d2 hybrid orbitals. The 6 sp3d2 orbitals are oriented in octahedral fashion making an angle 90 degree. 4 of the 5 half-filled sp3d2 orbitals overlap in a head-on fashion with the 2p orbital of a fluorine atom each to form 4 XeF sigma bonds, and the remaining one of the sp3d2 hybrid orbitals of xenon overlap in a head-on fashion with a half-filled orbital of oxygen atom to form one XeO sigma bond. The remaining unhybridized 5d orbital form a d pi p pi bond with the same oxygen atom to form XeO pi bond. The one lone pair on xenon occupies the position opposite to that occupied by the doubly bonded oxygen atom in order to minimize the repulsions. The number of lone pairs is 1, number of bond pairs is 5 and geometry is square pyramidal. Xenon dioxo difluoride. Molecular formula is XeO2F2. Synthesis of the compound when xenon hexafluoride treated with water giving xenon dioxo difluoride and hydrogen fluoride. We know the central element is xenon and the atomic number is 54. The ground state configuration is krypton 4d10 5s2 5p6. Promotion of an electron each from 5p orbitals into 3 of the vacant 5d orbitals takes place, which gives to an excited state configuration like this: 5s 5p3 5d3. One 5s orbitals and 3 5p orbitals and one of the 3 5d orbitals undergo hybridization, giving new 5 sp3d hybrid orbitals. sp3d orbitals are oriented in trigonal bipyramidal fashion. Two of the 4 half-filled sp3d orbitals overlap in a head-on fashion with the half-filled 2p orbital of the fluorine atoms and forming XCF sigma bonds. The remaining 2 sp3d hybrid orbitals of xenon overlap in a head-on fashion with a half-filled 2p orbital of oxygen atoms and forming 2 XCO sigma bonds. The half-filled unhybridized 5d orbitals form a d pi p pi bonds with the half-filled 2p orbital of the same oxygen atom and forming 2 XCO pi bonds. The lone pair on xenon occupies an equatorial position in order to minimize the repulsions between electron pairs. Number of lone pairs is 1. Number of bond pairs is 4. Geometry of the molecule is seesaw-shaped structure. Xenon dioxo tetrafluoride. Molecular formula is XeO2F4. Central element is xenon. Atomic number of xenon is 54. Ground state electronic configuration is krypton 4d10 5s2 5p6, and the excited state after promotion of an electron from s orbital and p orbitals to empty d orbitals. The outer electronic configuration after excitation is 5s1 5p3 and 5d4. The 5s and 3 5p orbitals and 2 5d orbitals of xenon mix among themselves with redistribution of energy to yield 6 new sp3d2 hybrid orbitals. We know sp3d2 orbitals are oriented in octahedral fashion. The angle is 90 degree and the 4 of the 6 half-filled orbitals of xenon overlap in a head-on fashion with the half-filled 2p orbital of fluorine atoms and forms 4 XCF sigma bonds, and the remaining 2 of the sp3d2 orbitals of xenon overlap in a head-on fashion with the 2p orbital of oxygen atom and forming 2 XCO sigma bonds. The half-filled unhybridized 5d orbitals form 2 d pi p pi bonds with the half-filled 2p orbital of the same oxygen atoms and forming 2 new XCO pi bonds. Number of lone pairs is 0 here and the number of bond pairs is 6, and the geometry of the molecule is octahedral structure, and bond angle is 90 degree. Xenon trioxo difluoride. Molecular formula is XeO3F2. Central element of this compound is xenon. Atomic number is 54. Ground state configuration is krypton 4d10 5s2 5p6. After excitation, the outer electronic configuration is 5s1, 5p3 and 5d4. The 5s, 3 5p and 1 5d orbital of xenon mix among themselves with the redistribution of energy to yield 5 new sp3d hybrid orbitals. sp3d orbitals are oriented in a trigonal bipyramidal fashion. The two of the 5 sp3d orbitals overlap in a head-on fashion with the 2p orbital of fluorine atoms and forming XeF sigma bonds. And the remaining 3 half-filled sp3d orbitals of xenon overlap in a head-on fashion with the 2p orbital of the 3 oxygen atoms and forming 3 XeO sigma bonds. The unhybridized 5d orbitals of xenon overlap in a sideways fashion with the 3 half-filled 2p orbitals of the 3 oxygen atoms and forming 3 XeO pi bonds. The structure of the molecule is trigonal bipyramidal. Bond angle is 90 degree and 120 degree. In this case, there is no lone pairs. In this table, the compound of noble gases, formula of the noble gas compound, and the oxidation state of central element, that is xenon, and state of hybridization of the compound and structure of the compound. Xenon difluoride. Molecular formula XeF2. Oxidation state is +2. Hybridization sp3d. Structure linear. For xenon tetrafluoride, XeF4. +4 is its oxidation state and hybridization is sp3d2 and its structure is square planar. For xenon hexafluoride, XeF6 +6 is the oxidation state, sp3d3 is the hybridization, structure is distorted octahedral. Xenon oxydifluoride XeOF2 +4 is the oxidation state, sp3d is the hybridization, structure is T-shaped. Xenon oxotetrafluoride XeOF4 +6 is the oxidation state, sp3d2 is the hybridization and square pyramidal is the geometry. Xenon trioxide XeO3 +6 sp3 pyramidal is its structure. For xenon tetroxide, molecular formula XeO4 +8 is its oxidation state and sp3 is the hybridization, geometry is tetrahedral. Xenon dioxo difluoride XeO2F2 +6 is the oxidation state, sp3d is the hybridization having seesaw shaped structure. Xenon dioxo tetrafluoride XeO2F4 +8 is the oxidation state, sp3d2 is the hybridization and octahedral is its geometry. Xenon trioxo difluoride XeO3F2 +8 its oxidation state, sp3d is the hybridization and trigonal bipyramidal is its structure. Thank you.